Hello friends, welcome to CodeBode. In the last video we saw unary and arithmetic operators. Now in this video let's see the next set of operators, that is shift operators. So here is our Eclipse IDE. And after unary and arithmetic, next preference is taken by shift operators. Again there are two types, left shift, right shift. So first we will see left shift operators. Now left shift operators are denoted by two angle brackets as such. The left shift operators shifts the value of a variable or a number by given bits. Let's take example to understand this. So let's say we have a variable I and let's assign it a value of 4. Now shifting bits means shifting the binary bits. So first, let's write the binary representation of 4, which is 1, 0, 0. Now we will use left shift operator on the variable I. So I'll directly print it. So sys out I. So first we take the variable on which operation is to be performed. Then left shift operator. And then let's say we want to shift it by 2 bits. So I'm going to write 2. So here 4 will be shifted by 2 bits. So when number is left shifted by 2 bits, 2 zeros are added at the end of the binary representation of the number. Always only zeros are added. So binary representation was 100. After left shift, 2 zeros will be added because we are shifting by 2 bits. If we shift by 3 bits, 3 zeros will be added. So the output of this print statement will be 10000, which is 16. So in this way, left shift operation works. There is another shortcut formula to calculate this. So when I say 4 left shift operator 2, calculation goes as 4, that is the number on which operation is performed, into 2, this is constant, it stays 2, raised to the bits we want to shift. So here we are shifting 2 bits, so it is going to be 4 into 2 raised to 2. So the answer is 16. Now if we shift by 3 bits, it is going to be 10000, which is 32. So by formula it should be 4 into 2 raised to 3 because 3 bits are shifted, which is 32. Let's run and check. So here we have our output 16 and 32. 16 for 2 bits, 32 for 3 bits. Now let's see the right shift operator. So they are represented by opposite angle brackets. And in the right shift, last digits are removed and zeros are appended before the number. So if I say I, right shift operator 2, so I was 4, 2 zeros at the end of 4 are going to be removed and 2 zeros will be appended at the beginning of 1. So in this way our answer is 1. So no matter what bits you have at the end of the number, they are going to be removed and new zeros will be appended before the digit. So for 5 right shift 2, so representation of 5 is 101. Last digit, be it 0 or 1, will be removed and 2 zeros will be appended before 1. So in this way, again the answer is 1. So again the shortcut for this is, so let's consider we take the shortcut for 4 right shift 2. So it is going to be 4 divided by. In the left shift we had multiplied, in the right shift we divide. So 4 divided by 2 raised to the bits we want to shift. So 2. So the answer is 1. So in this way, left and right shift works. I suggest you try with more numbers such as 8, 16, 5 and check what output you get. In the next video, we will learn about relational operators. Until then, stay tuned, subscribe to our channel, also like and share this video. Thank you.